What's going on, everybody? It's Kistner again, and today we are talking about Section 4, dash 4, Section 4.4, adding and subtracting rational expressions. Now, last time we talked only about multiplying and dividing rational expressions. This one's actually a little bit more time-consuming because you have to have a certain thing before you can start adding and subtracting rational expressions. So, I don't want you to forget, like I said last time, that rational expressions are just polynomials in the form of fractions, or fractions that have polynomials for the numerator and denominator. So every rule that applies to adding and subtracting fractions will also apply to this. So if you know how to add and subtract fractions, this is more of a just apply those rules to polynomials. So let's get into it. You'll be on page 104 in your student companion, I believe. I believe it's right around 104. Look for section 4.4, example 1. Try it, and it should look like this. 10x minus 5 over 2x plus 3 plus 8 minus 4x plus 2x plus 3. Now, when you add fractions, remember you have to have common denominators, or this book calls them like denominators. And that's what this example is about. It says add rational expressions with like denominators. So they've already given that for us. And remember, when you add fractions, you add straight across, but you don't change the denominator. So we just add everything that's on the top. So really, if we were going to put this as 1, you don't have to do this every time. You can combine like terms without doing this. But I'm going to write it as is all over 2x plus 3. Okay? Now, we can combine like terms on top. We get 10x minus 4x, that is 6x. Negative 5 plus 8 is positive 3, all over 2x plus 3. Now, right now we cannot cancel anything out. It looks like we should be able to cancel 6 and a 2, make it 3x, and the 3 and a 3 make it 1. We can't do that because of these plus signs. We're not multiplying and dividing, we're adding and subtracting here. So, but what I can do is I do realize that this top one has a 3 in it. So we're going to say 3 times 2x plus 1 all over 2x plus 3, and we're done. This is our final answer. That's the sum. That's the addition. That's what you get when you add those two fractions. Now, you could have also left it like this. Either one of these answers is okay. I just went ahead and simplified it a little bit more on the right. Okay, we'll do part B in class. So go ahead and turn to page 2, or example 2. Identify the least common multiple of the polynomials. This is going to be important in order to know what our denominator is going to be when we start to add things that don't have common denominators. Least common multiple is a thing you learned way back in elementary school. So let's refresh it with rational expressions. So the first thing we need to do is factor both of these polynomials. This is a weird one where it's a cubic, and you can't factor something out of all of them. They're not all divisible by 3. They don't all have an x in them. So what we're going to do is get out our calculators. This is the easiest and the quickest way that I know. Get out your calculators and type just this part in to your calculator and see where it crosses the x-axis. All right, so go ahead and get your calculator up and type in x to the third. And my computer's going to start jumping around because it's slow, plus 9x squared plus 27x plus 27. Oh, sorry, I did that wrong. You need to type that into y equals. I'm having a little slow morning. Type that into y equals x cubed plus 9x squared plus 27x plus 27. Now, we could have done this a bunch of different ways. We could have seen where the leading coefficient, the constant over the leading coefficients, and we would have used plus or minus 1, plus or minus 3, plus or minus 9, and plus or minus 27, all over plus or minus 1, and kept plugging them in until I got a 0. But to me, this is the easiest way. If you just hit zoom 6, and you figure out where this thing's going to cross. Hopefully we see it cross at least once. And it does. It crosses right here. So we're going to use our second trace feature, and we're looking for a 0. We're looking for the x-intercept. So I'm going to scroll down to 0 and hit enter. And I'm going to scroll to the left till I see my clicker, because I see it's at negative 9.9. So here it comes right here. And get to the left-hand side because it's looking for the left bound. We did this a lot before winter break. And scrolling to the right. And I'm going to guess. Just hit enter a couple times. And it tells me it is right at 3. This 0.73, this 73 over here, don't worry about that. It is right at negative 3. So what that tells me over here is, one, let me get rid of this calculator for a second because it slows everything down. One of my roots is x equals negative 3, or a factor is x plus 3. That's what's going to come in handy in a second. But I now know that I can do synthetic division with negative 3, because that is one of my roots. So now I put the coefficients, if you remember how to do synthetic division, 1, 9, 27, and 27. And whoops, draw your line. Drop the 1. You get 1, you get negative 3. That's 6. Negative 18. That's 9. Negative 27. Remember, you multiply. And that gets you 0, which is your remainder, which is nice. Now, remember, this started off as a cubic, so this becomes a squared term. It's x squared plus 6x plus 9. And we have this x plus 3 that is still being multiplied by it. So this thing inside the red parentheses is now x plus 3 times x squared plus 6x plus 9. And we can factor that one more time. Be 3 and 3, be x plus 3, and x plus 3. So this is x plus 3 cubed. We have it 3 times. So now we come back up here and we try to factor what's inside these blue parentheses. And to do that, that's going to be a little bit easier. That's going to be x, and I believe it's going to be 3 and 7, and negative 7 plus 3. So when we find a common denominator, if you look, we need x cubed, and what is this one's missing? The x minus 7. So our least common multiple here is going to be x plus 3 cubed times x minus 7. Now the way you remember this is you list all of your factors, like I listed x plus 3 and I listed x minus 7, and the exponents are the highest exponents that you see in either one of your multiples, or in either one of your expressions. I'm sorry, wrong word. So here, this had a 3 and this had a 1, so I chose the 3 to put on that x plus 3. The only one that had x minus 7 was a 1, so there's only one of those. We'll do that again in class down here when we have 3 expressions. We just have to do it 3 times. There's nothing special about it. So go ahead and turn the page to example 3. Find the sum. Now, we don't have common denominators. We need to find the common denominators. And just like we did when we multiplied, we need to factor, or multiply and divide, we need to factor these to see, first off, to see if anything cancels, and that'll help us find the least common multiple and our common denominator. So when I factor this bottom one, that's the difference of 2 squares. So this is going to be x plus 6 all over x minus 2, x plus 2. And over here, I'm going to get 2 all over, and that's going to factor into x and x, 6 and 1, and it's going to be negative 6 plus 1. Sorry, no it's not. I'm wrong again. That's the real easy way to go because it seems like it's the right numbers, but it's not. Because negative 6 plus 1 gives me a positive 5. Or sorry, negative 5, that gives me a negative 6 here. So what I need is a 3 and a 2, and I need to switch the signs. They both need to be negative. Okay, so over here, this is x minus 2, x plus 2, and x minus 2, x plus 3. So the highest exponent on any of these is a 1. So my least common multiple for my denominator is you just list each one of your factors. Each one had an exponent of 1 as their highest, so we list them as a 1 here. Okay? If you think about it, this needs an x minus 3, and this needs an x plus 2 to match. You want to make them be the same thing. So this is what the match would look like. Now, that means I need to multiply the top and bottom here by x plus 3. Okay, so I'm going to get x plus 3 times x plus 6. That's this first one. And over here, I need to multiply this one. What does it need? It needs an... Oh, I forgot one up here, didn't I? I almost did it again, actually. It should be x minus 3 here, shouldn't it? Go back and make sure you have that right, because I have messed that up multiple times. And this should be an x minus 3. Sometimes you make a little bit of mistakes. It's okay. As long as you catch them quick. Alright. And this one needs an x plus 2. So I need to multiply the top and bottom here by x plus 2. So I'm going to get over here 2 times x plus 2. And it's all over our least common multiple, or our common denominator, x minus 2, x plus 2, x minus 3. Now, what do I put in the middle? Well, there's a plus sign, so I'll put a plus sign in the middle of it. And now I'll look to see, can I cancel anything out? And right now I can't because of this stupid plus sign in the middle. I can't say, oh, x minus 3 and x minus 3 and cancel it. Then that just takes me right back to where I was. So what I need to do is multiply all of this out. So if I distribute these two together, x times x is x squared, x times 6 is a positive 6, x minus 3x is plus 3x minus 18. And then that plus sign, and I get 2x plus 4 all over x minus 2, x plus 2, x minus 3. Up top, I can combine like terms. I have x squared, and that goes away. I have 3x plus 2x is plus 5x, and these can go away. And then I have negative 18 plus 4 is minus 14 all over x minus 2, x plus 2, x minus 3. And now we're just factoring. Now we're back to a problem we did last class where I'm going to try to factor the top again. Because it's a brand new polynomial now. And what it'll factor into are two binomials, x and x. And I need to multiply to get 14, and be 5 apart. I believe that's going to be 7 and 2. Different signs, middle number's positive, so the bigger number gets a positive. X minus 2, x plus 2, x minus 3. And here, finally, my x minus 2's will cancel, and I'm left with my final answer of x plus 7 over x plus 2, x minus 3. And this is our final answer. Long problem, I know, but that was because we had to find a common denominator, then distribute, then refactor. That takes a little bit of time. I'm going to pause the video here on example 3. You guys have a great day. Make sure you've done your work and you've taken these notes by the time class starts. And this is Kistner out.